In the given problem, we have to find out the output power spectral density in terms of the input power spectral density. For that, we need to know the relationship between the output power spectral density and input power spectral density, that is given as follows. Output power spectral density Sy of f equals to the transfer function of a system square into input PSD. In order to calculate the output PSD, we need to know the frequency response of a system. For a system, impulse response and the frequency response are the Fourier transform pairs. H of t is nothing but an impulse response. To find out an impulse response, we need to apply an impulse as an input signal to a system. If input is equals to an impulse signal, then output y of t equals to an impulse response. Then h of t equals to t minus t del of t into dt equals to 1 if and only if t greater than or equals to 0, less than or equals to t. Hence, h of t equals to 1 if t is greater than or equals to 0, less than or equals to t, otherwise it is 0 elsewhere. If you find out the Fourier transform for this particular impulse response, we will get after getting frequency response, we have to substitute this expression in the equation 1. Then we will get the output PSD as follows. Answer is in the above question, we need to find out the PSD of a in-phase component. So the given data is the PSD of the narrowband noise and the carrier frequency Fc equals to 5Hz. So to find out the PSD of the in-phase component, we need to know the relationship between the narrowband noise PSD as well as the in-phase component of the in-phase component. That is given as follows. The PSD of in-phase component or quadrature component of noise is given as Sni or f or Snq of f equals to Sn of f plus fc plus Sn of f minus fc. F in between b equals to 0 otherwise. We know Fc equals to 5 Hertz. If we perform or find out Sni of f by using above expression, then we will get the answer as option B. In the above given problem, we have to find out the mean of the output whose unit sample response is mentioned in the problem. The output of a system whose impulse response is h of n and input is x of n, output is y of n. The relationship between in output and the input is given as follows. R x of m h of n minus m. If we apply the mean to the output equation, that is expectation of y of n is equals to the expectation of then summation over m h of m expectation of x of n minus m, which is given in the problem is 0, because x of n is a white noise process whose mean is equals to 0. Hence the output mean is equals to input mean multiplied with the frequency response at f equals to 0, whose value is equals to 0.